All right, good afternoon, everyone. Thanks again for joining us. We are here to learn about residential compliance forms for permitting. We have Jennifer Rennick and Grant Murphy with Imbalance Green Consulting. But before we get into the content, I just have a few slides to run through. So we're all very familiar with Zoom. We just ask that you make sure that you're on mute. But if you have a question, feel free to raise your hand. We'll ask you to unmute yourself, or we'll be monitoring the chat as well. Next slide, please. So a little bit about who we are. We are the Tri-County Regional Energy Network, or 3C-REN. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C-REN is funded by ratepayer dollars, which are collected through the public goods charge found on our utility bills. 3C-REN currently offers 3 programs. The first of which is our Energy Code Connect program, which serves building professionals by offering Title 24 support for everyone from plans examiners, inspectors, to architects and contractors. We have 3 main services: our Energy Code Coach, and our trainings and support. And we also have our regional forums. And next slide. Another program we have is our Building Performance Training, which serves current and prospective building professionals with technical and soft skill education. And then our third program is our Home Energy Savings program, which incentivizes contractors and helps residents save money to make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Jennifer.
I'm glad you could join us here. Today, we do have, for those of you who are architects, if we have any architects on the call, actually let us know in the chat, let Grant know. If we have mostly plans examiners, builders, architects, folks from the CEC, that gives us an idea of kind of who the audience is. And today's learning objectives, the main thing is really to go over the Title 24 2022 residential energy code compliance forms. Specifically, the CF1R is the one we'll be looking at today, and there are AIA learning units available for this. If you're an architect, let Sarah know in the chat or an email afterwards so you can get your units. Basic concept of the forms for residential single-family construction, and granted, this may be a review for some of you, but if you're new to the code, it's there's 3 types of forms that we'll generally be talking about throughout this, and the CF1R form is used to show compliance with the energy code at the initial plan submittal. The CF2R forms is used during construction to show the energy code features that meet the installation requirements, and the CF3R forms are also used during construction to show that the features meet the verification requirements. So today we're going to focus on the CF1R form, and kind of another way to look at this and to introduce you to the vocabulary word HERS. It's for Home Energy Rating System, and that might be new to some of you, but we have 2 HERS providers, CalCerts and Chairs in California, and these organizations are responsible for training and certifying the HERS raters, which are people that come out to the residential home site during construction, and they support in the California Energy Code and Registry. So basically, we've got design submittal, construction, and final occupancy is kind of this big overview. And then during the design submittal for permit, that's when the CF1R compliance form is created and it's uploaded to the HERS registry. And then during construction, There's going to be a CF2R installation that'll be completed. Well, I should say forms, typically plural there, and uploaded to the HERS registry. We also have the CF3R verification forms that are completed and uploaded to the HERS registry. And then at final occupancy, this is where the building official confirms that the CF2Rs and CF3Rs are air quote cleared, and they look to make sure that everything on those forms have been met. We're going to go over the kind of the CF2R, CF3R, and that clearance a little bit more in the second part of this presentation, which is going to be on the 29th of November. And then in January, February, sometime, we're going to go into more specific details about a lot of these HERS measures. And today, we're going to really kind of stick with a high level with the CF1R. So the CF1R PRF for performance 01E form for the 2022 Energy Code is for single family construction. And the first sheet basically looks like this. And what we're going to do is kind of go through all the sections that are part of the CF1R performance form today. And we're going to highlight which pieces of information would be most useful to the plans examiner. But we're going to also hit on like which of these things would be useful to the designers, which of these things would be useful, architects or designers, which of these things would be useful for the builder to really take a look at, and kind of highlight here and there what needs to go in the plans. If you have questions, put it in the chat, or if there's only a handful of us, unmute or raise your hand and just ask. We want this to be as interactive as possible, because really there's actually a lot of information on these forms. It's just that not every piece of information listed is useful to every trade or every discipline in the whole construction process. So just right off the bat, what makes this thing like an official CF1R form for permitting? It's that it's watermarked. And this particular one, these particular excerpts I'm going to show you have all been watermarked from CalCerts. And you could have one that's watermarked that says cheers. And then the other thing about these forms that a lot of plans examiners want to take a look at is the registration date and the number, which is at the top of this whole form, just to see that there's a consistency with every page of the report, that it's matching, and that this whole report goes together. Today, however, I'm not actually showing you one report. These are bits and pieces of multiple reports. So you're not, and I also gave them like, it's this called New House. And I gave it a crazy name like 123 New Street. And, but it'll give you an idea of what you could see on the forms. And on this particular form, some of the top things you're going to want to look at is, for example, box 8, just make sure you're in the right climate zone. The climate zone is going to be determined by what the energy modeler chooses, but the project location and even sometimes the city won't be, or zip code won't be an indication of the actual climate zone. So you really want to take a look at a box 8. And then box 12 for the project scope. That's going to show up as saying it's newly constructed, or it's an addition or an alteration. And then following that, if it is an addition, box 14 is going to populate with the square footage, the floor area for that. Box 18 is going to give you your total condition floor area for that project. Box 16, yes, it's going to populate with an existing condition floor area if your project is alteration and it's included in that. Otherwise, really, as a plans examiner, you look at that addition floor area and you look at the total floor area, and is it consistent? Does it match? The other thing, as a plans examiner, you're going to really want to take a look at the dwelling units. It's either going to be 1 or 2, because technically a duplex is single family. The number of bedrooms is important. And if it's an ADU, box 20, you'll have a bedroom ADU content as well. And then box 15, number of stories. These are kind of the main ones you're going to want to look at. And specifically, if you see something with box 11, 13, 20 with that bedroom count that's not matching the plans, that would be reason to send it back, because as it turns out, these bedroom counts are significant because they dictate how much outside air is required for the IAQ ventilation. So even as an architect, and you're just getting the draft report, or as an energy consultant, and you're doing this for your client, that's one of the places I look at right away, just to make sure you get that bedroom count, because your results will change a lot if you accidentally did a typo on the bedroom count or forgot to update it. And Grant, jump in if there's anything on these that you think are significant that I should hit on.
Yeah, absolutely.
Yeah.
I just wanted to go back. Kind of the reason we came up with this in the very beginning was trying to provide something that was a quick overview of reviewing these CF1Rs for plans examiners. Jennifer's going to detail more than just that, but we were coming from a perspective of speed. So we really were selecting what we found was the most influential and impactful parts of the form. So just wanted to chime in.
Oh, yes, absolutely. And at the end of the slide deck, and you're going to get a copy of the slides, we've included that list as a compact document with these things listed, a little more explanation, and a place for your notes. And so that's part of the resource you'll get on the slide deck, but also you can get that resource from 3C Ren's website. And I'll show you what it looks like at the very end, but we won't repeat, going through that list. That list, it will include the most pertinent pieces of information that Grant was talking about. And I'll hit on some other stuff that's not necessarily on the list, just to help folks get more familiar with the whole document, so they understand what it is, and maybe also understand why some of these things aren't listed. So with that in mind,
Jennifer, we have a quick first question asking, what if there's no watermark on the calcs?
Then it's not valid for permitting.
Perfect.
So it has to have the watermark. It has to be registered with the HERS registry. Now we're in a little bit of a situation with multifamily right now. That so right now, single family residents, new construction, alteration addition, or alteration plus existing and addition, all those will be on the HERS registry and be watermarked.
Perfect.
So yes, page 2, watermarks there. Let's see, the calculation date and time match. That's the quick check, super quick. The result, pass? Yep, it passes. And then just FYI, a little bit of side information is that this project will have a PV system, and the PV system size is listed at the bottom, and it's kind of a quick FYI, and it tells what it is. But dig in a little bit deeper on this is that we know that it complies because there's something called a source energy that is like a metric for carbon impact, and it's a proxy for a carbon footprint, and that has a positive compliance margin. There's an efficiency, EDR, known as EDR2 efficiency, and that is also positive. And that has a lot more to do with how the building itself is performing. And then there's a total EDR too, which includes that efficiency, and it includes some demand response measures such as photovoltaics and batteries, which is also noted in the little footnotes below. And this EDR metric on this page, on the second page, it's been normalized so that it's essentially a scale from 0 to 100. And the idea is if you have 0 in your total, eventually you would have like a 0 net energy project. That was kind of the idea behind it in the beginning. And now we just look to see, are all those things positive? Yes, it's a passing report. Now, this third page typically is the energy use summary. It's got some overlap, but it's a different metric. And this report here, I have not found to be useful for plans examiners at all. So we, when you look at the handout at the end of the slide deck, we don't say anything about this, but this sheet is very useful for the energy consultants, and it can be useful for the architects or designers who are trying to better understand their project and how it's performing. So we have a similar metrics with our source energy EDR1. I mean, how it's valued does not, you won't see a one-to-one match with the previous table I showed you, but there'll be some correlation, some useful information. And then there is a design TDV energy EDR2. You all can ask me at the end if we could go into TDV and the KBTU per square foot year metrics, but I don't think we have time in this class to go into that detail. But I think what is useful for the designers and the energy consultants is to take a look at this part of the table where you've got space heating, space cooling, IAQ, ventilation, and water heating. Those are the regulated energy uses for Title 24. And this is where you're going to get a clue of how your building is performing so that you can hone in on the areas that need improvement and give that feedback to the architect, or the architect can look at this and say, okay, wow, in this case, our ventilation is a 0 compliance margin. Okay, we're meeting the baseline, no problem. But wow, look at the water heating. Those last numbers, we have negatives in those compliance margin columns. So that tells me some work could be done on the water heating, and there might be possible credits or a different water heating system that needs to come in place. And then another portion of those regulated loads, or rather where you could get credits or penalties, have to do with self-utilization or flexibility credit, which is indication that there's batteries and there's photovoltaic system included. And then the last line, there is a battery system included. Okay, and then the unregulated energy use loads, indoor lighting, outdoor lighting, plug loads, appliance, and cooking. These I find just useful for the designer, for the homeowner, if you want to get into it with them, just to give them a sense of the relative proportion of how much energy use could go into their plug loads and appliances and cooking based on regional averages, and that compared to how much energy they might use for space heating. So in this particular example, they're going to use many, many times more energy on just living in the house than they are with the actual requirements for heating the house. And really that PV system is going to help offset a lot of those loads. Okay, now we're getting back into kind of we're starting to get into more of the meat of the report. However, energy use intensity, this is another one we just kind of bypass if you're plans examiner. And this energy use intensity uses another metric. It's called an EUI. And for energy use intensity, we don't see this coming into play much at all. Could be interesting to some folks, but it's there. So typically we just skip over it. But anyone on the CEC call, I don't mean to offend. I'm just joking around. The intent, though, was to just help the plans examiners and folks save time, because it's not going to matter what it says, really, at this level. And then the PV system, we're basically looking, is it a standard design, or did the energy modeler put in a custom design? And this, right now, we just have the one line, it's standard. This basically means, hey, homeowner and builder, you're going to have to put in a system that meets this minimum requirement, but we haven't put in a actual system you might use. And battery system, if applicable, it will also list the size and capacity and some other metrics that you would need in order to use that as a credit. So a lot of the items on this page we would skip over. Now, next in Title 24 will be the required special features. These items could be really important, but it depends. It depends on which items are listed. And when I say important, I'm specifically coming from that point of view of if you're a plans examiner and you're trying to get through this report quickly. So what I did here is I excerpt three required special features blocks from 3 projects we had. And the first 2 were part of CalCert certified projects. And then the bottom one was just a draft Title 24 I had done. And this kind of gets back to the other question that someone had, like, if it's got the watermark on it, yes, it's good. But if it sees, and you can kind of see, I don't know, my cursor here, this part is just the gray watermark going sideways down the page. And that's an indication where it says this is not for compliance. And it's just a draft. But anyhow, this can be very interesting to take a look at. So some of these items will show up, or maybe should show up or be noted on the drawing set. So for example, if you've got insulation above and below the roof deck, as is the case in the first or the top set of special features. Another thing that could come into play is the battery system will be noted here, and just gives you a heads up. Hey, there's going to be a battery and they took the self-utilization credit. So you'd expect to see some note or something on the plans indicating the battery and where the battery system would be located, because there are requirements that go along with that have to be code compliant. Same thing like duct location. It kind of alerts you, hey, this middle one says ducts are going to be in the crawl space. Okay, that's typically, we see them in the attic in our area. So ducts in the crawl space is unusual. I'd expect that to be noted on the plans, or at least have a crawl space that is large enough to accommodate the ducts. On the last one, this has what's called a variable capacity heat pump compliance option credit. And that is going to trigger a lot of HERS features, which I'll show you in the next slide. But that kind of gives you a heads up that that's going to be part of it. And then the other things I would point out is if the project is noting that there's a point of use plumbing credit taken, or compact plumbing distribution system credit, because those two I would expect to see on the plan set, like your hot water heating system, very, very close to all the hot water uses. And so that could give you a heads up as a plans examiner that if they're not close together and there aren't calculations that go with it, that perhaps point of use plumbing credit, compact distribution system credit is not appropriate. So you could ask for a justification on that. For the HERS feature summary, which is the very next section. Oh, and then maybe I should point out, on your Title 24 forms, I'm going in the order that you would see these tables listed, but these tables don't have a number 1 or a letter A, B, C, D to reference. They strictly are listed in this order, and they go by their main name. Oh, sorry about that. I'm gonna go back one. So these HERS feature summary tables, these listed items may or may not impact the drawing set, but one thing they all have in common is that all the HERS features must be field verified. And typically these items will not impact the plan check process, but these listed items should be very important to the builder and may benefit the architect or the ownership. And because of that, some of these features may, this might be beneficial to have them on the plan set. And an example of something that you would see on the plan set that would be beneficial to the homeowner is, for example, on the HERS feature summary on the upper right, is that the variable heat capacity credit was taken. Okay, good. However, in this case, it's for a ductless, completely ductless system. So it's kind of a big deal that all the ductless indoor units are located entirely in the conditioned space. That could be important for the architect to understand and the homeowner to understand, because maybe they're not a big fan of wall-mounted or floor-mounted ductless units, or perhaps they're doing recessed ceiling ductless units. But now, as a plans examiner, you would expect to see information detailing that those ductless units recessed into the ceiling are within the conditioned envelope. So it kind of goes back to, is all the insulation up at the roof deck and below the roof deck? And we have an unvented attic. Grant, anything you want to add on this?
The next presentation, Sarah, on the 27th is going to go into
29th, I think.
29th, thank you. Is going to go into much further detail on the specific HERS features. We wanted to highlight this here because it's really important in coordinating between disciplines, design team, builder, plan check. We've seen a lot of issues at the stage of trying to get final and CF2Rs, which again, we're going to go over in the next presentation, aren't in alignment with what got built, and then trying to retroactively change Title 24s and drawings. It gets really messy. So this is something that everyone in the industry should be aware of, because it can cause roadblocks to projects. Again, please tune into the next presentation, and Jennifer and Paul, a local HERS rater, will be going over that in great detail.
Yeah, right. That's right. So again, it's sort of like, as a plans examiner, you could go, yep, they got a bunch of HERS stuff. I'm expecting to see the CF2Rs and 3Rs and make sure all that, the guys in the field are dealing with that, or, it's all part of the final. But, the architects, your energy consultants, and your builder and your homeowner, like, you all would need to get on board with all of these together, which is because of what Grant said. So anyhow, the next section after the HERS feature summary is having to do with the building features information or zone information and opaque surfaces. So the building features, this table, some of it repeats because we already know, for example, the project name is New House, and we've got a conditioned floor area that's consistent with the cover sheet, number of dwellings consistent, number of bedrooms, those auto-populate. all those should be fine. And now we're looking at, well, how many zones are we dealing with? How many ventilation cooling systems are we dealing with? Not air conditioning, but like for some of the climate zones, like climate zone 9, you might have a whole house ventilation cooling fan, that comes on periodically to really, when you have your doors and windows open, so you can really pull in cool air and evacuate the hot air, that type of system. And then the number of water heating systems. So the zonal information now gives you a little summary on each zone, which, you know, if you've got, in this case, we've got one zone, one item populates, but perhaps we have multiple zones, so that table could be fleshed out quite a bit more. And then the opaque surfaces, really we're talking about walls and floors here. And this opaque surfaces table can be quite lengthy depending on the size of the project. This is a little small, simple floor plan house that we're using to demonstrate this. And I just excerpt, you know, the top 4 items off this table, which corresponded to the walls. Now, what I'm going to do to illustrate a couple of concepts here is I'm going to take this part of the table and on the next couple slides expand it out and just review a little bit about what's going on with the columns and kind of set you up for the format that we're using for the rest of the presentation, which really delves into those items you might want to spot check. And up until now, a lot of these things, a lot of it was informational in the sense of helping you all understand just what goes into these Title 24 forms a little bit better. Now, as an energy modeling, energy consultant, yes, I spot check everything we've talked about. And, you know, Grant does too. You get in a good habit, you know, right where to look to catch certain things. But if you were a plans examiner and you only have a few minutes, we're going to highlight some of the main stuff. Okay, so here's that table again. And I just could point out, this is kind of consistent throughout a lot of these tables. The names, what things are called, it's manually entered by the energy modeler. So I could call this name anything. We just happened to use the default and call the south wall south, but I could have called that thing anything. So you could pretty much ignore it. And same with this construction type. As a plans examiner, if you see something that says R19, 2x6, you might think, oh yeah, they put an R19 cavity fill in that 2x6 stud wall. But that name is made up. I could call it R30 in a 2x8 and not actually model that. So I'm just giving you all a heads up as a plans examiner. Don't pay much attention to the construction names. Those are more of a reference for the energy modeler themselves. Same thing with the orientation. It has to do if you're rotating the building and you're doing all 4 orientations. Okay, but, oh, and also you can pretty much ignore the tilt as being 90 degrees for the walls. I mean, if you see something that's not 90 degrees, it might catch your eye, but typically they're 90 degrees. Okay, so let's assume now that those items can be ignored. Then that leaves us with these other columns, which in our opinion is kind of important. And even this is a column 2. And this formatting too of listing out the column and its name, column and name, I'm going to do that on the other slides, but I'm not going to parse them out or do this animation. We're just going to give you a slide with the summary, but the format is that we're calling out the columns across the table on each of these and kind of pointing out the information that's important to you or could be most important to you. So Column 2, the zone, that's interesting for the energy modelers because that tells me I have a zone that I named conditioned floor area, and it just is telling me what that parent-child modeling relationship is. So it just lets me know what zone it's in. But for plans examiner, the column 4 azimuth, yeah, that needs to match the plans. And so we recommend that you use your best kind of sampling practices to compare to the site plan. So you know certain quantity of wall is going to face south, for example, and a 180-degree azimuth is south facing. So it's worth knowing your cardinal directions and taking a look at the site plan. But that pulls in directly to column 6 and 7, the gross area for assemblies and the window and door area. And here you can get a pretty good handle on spot checking and using your best sampling practices to compare to the plans and elevations. So for example, I see that there's a gross area on the south and north wall that's equal to each other. Okay, that kind of makes sense. The east and west wall don't quite match. So it could be that one wall is taller than the other, or it could be that they're the way the walls are running, that there's a difference that you might want to note. We've seen situations though where these don't match, and then as an energy modeler, we got to go back and double check it because maybe there was just a mistake. And then the window and door thing also needs to match. So that kind of gives you this format. And now we're going to kind of plug through a bunch of the different tables and highlight what to look for. And again, you do get a copy of the slide deck. So next would be the opaque surfaces, specifically cathedral ceilings. And similar to what we just looked at, the names don't matter so much. Azimuth is important. The area is important. And in this case, the roof rise could be important if you've got a steep roof or if it's a flat roof. So 1 to 2 is a pretty flat, but 2 and greater is a sloped roof. Columns 9 and 10 deal with roof reflectance and emittance. If you see a 0.1 in your roof reflectance and a 0.85 in the roof emittance values, those are default. And it's pretty typical to see those. And it means that the energy modeler and the architect and the builder, no one's really looking into a cool roof, or CRRC, Cool Roof Rating Council. And I put a little excerpt there on the right in the orange box for you. That is straight off, that kind of definition is straight off the CRR website. And I put the coolroofs.org website there so you could get further information, and also where the products directory of cool roof rated materials lie. So in this case, it even says cool roof. No, they're not trying to take a cool roof credit. You move on. If yes, then you're going to want to confirm those values with the material specs. Opaque surfaces, specifically now the attics portion, kind of the same. The names, not so critical, but column 3 is kind of a big deal to note whether it's an unvented or a ventilated attic. And this could come back into play with where the ducts are located. So it's good just to confirm with the plans. Roof rise, same sort of thing. Notice if it's a flat roof or a steep roof. Solar reflectance in the cool roof, same as the last slide, but the attic does now include column 4 radiant barrier, column 7. And it's one of those things that if they are claiming a radiant barrier, then I would expect to see a call out on the drawings.
Jennifer, there's one thing I wanted to point out there.
Yes.
So column 1 is a manually input item that you can write as anything. Column 2 is the same, but it's gonna relate to something in a later table when we talk about what the actual construction assembly is. So 1, it's like when you input the actual component. 2 is how you define that component. And I just want to clarify that because we're going to get to the table where those components are defined and there's useful information in that table. When you're trying to understand what correlates to what, this is where if you go, hey, what is attic garage roof construction? Oh, it says it's a R19, R30, whatever it is, dimension lumber. You come back to this table and that's how you would be able to tie those two together. But at this level, it's not actually important until you have to combine them.
Yes.
Cool.
Yeah. Good point. Thank you. The fenestration glazing. So fenestration, fancy word for the windows or glazed doors. In the other tables, it actually says windows and door area. Here, we're just saying, okay, fenestration and glazing. Basically, if you've already confirmed that the direction, the azimuth of the opaque surfaces on those other tables was correct, then basically columns 3 through 5 will be correct because it's a repeat of that because the window is in the wall. So if it's in the wall faces the right way, the window's that's facing the right way. Columns 10 and 12 for U factor and solar heat gain coefficient. This is something where you would expect to see a correlation between the plan set. This is something I think is really important for the energy consultant and the architect and the builder to get on the same page because you can get triple paned windows, you can get windows with high solar heat gain coefficients. And then for some climate zones, really high solar heat gain coefficients give you a huge compliance margin, even though it's almost impossible to get some of those windows. So one hand, it's like plans examiner, you're looking for accuracy, looking, okay, are these folks cheating the system? But as a builder, you look at this, you really want to pay attention because you're going to be, ideally you would be responsible for making sure that these values are met. And then when you see all the values just the same throughout, it means we're basically using a generic value in that range until the actual windows and doors are truly specified. And the column 9 for the areas, yeah, those should match the plans for sure. Anything you want to add on this one, Grant? Oh, Grant's on mute.
Sorry.
So
Nope, I'm good.
Okay. Overhangs and slabs. So they're not really related, but they do come after each other in the tables on your CF1R forms. So for the overhangs, this can be useful for the designers to really take a look at and as a way to help with the energy performance feedback to the designers. And just FYI, the units in this table are in feet. So when you talk about a depth, it's the 1 foot means the overhang is a 1 foot depth. And the dist up, it means distance above the window, just in case that wasn't obvious to everybody. This is important, most specifically, I think, for south and west orientations. For our climate zones, that's kind of important. That's where we'll see the overhangs and side fins and right fins modeled. But it may not be necessary to model like your north-facing windows, for example. And sometimes you won't see short overhangs or overhangs that are quite a few feet above a window. It's not even worth the time to put them in the energy model. So as a plans examiner, you know, you got to maybe take a look at that and figure out if they were ignoring them because it's not significant, or it's just another way that they're just trying to get not a good project. Okay,
Yeah,
so
it's really common not to see any overhangs and fins to be modeled when reviewing, you know, bulk tile 24s. I always recommend that if there is something, you check, because modeling overhangs or side fins on substantial glass at certain orientations can be a good improvement for a project. And if those aren't real, that's kind of a cheat. So when you do see them on the report and they're, you know, they don't exist, that would be a red flag. But otherwise, it's something that is time consuming and often you move past if they're not there.
yeah, and in many cases, they're just not going to do anything as far as having a big impact on the energy use, given the orientation, given how far away they are from the window. So I would agree with Grant, most of the time you're not going to see them. But if you do see like a house with like huge, you know, like 6 feet, 8 feet long overhangs, I would expect to see those modeled. Okay. Slab floor, the biggest thing here is just to note if the slab is actually heated. So the very last column, if it says yes, that's significant because it triggers under slab insulation, which is a required measurement. So it's not really showing up anyplace else. The carpeted fraction, actually column 7, could be significant if there's no carpet anywhere, but the plans are not calling for an exposed slab that's being decorated. Otherwise, we're just looking at, is there slab edge insulation or not? And that really would need to show up on the plan set. Okay, for opaque surfaces, construction, same sort of thing. Got your name, you got your surface type. Now this is where we get into what's actually going on here. And there's the total cavity R value and a continuous kind of interior exterior continuous R value. Those are important in plan check to pay attention to. And 8 assembly layers, you can basically make those say anything you want to. Same with your construction name. Same with some of these other values. So kind of a heads up, I would just focus on total cavity R value and continuous R value. And did those seem consistent? And then the HERS envelope, HERS verification. This is like your HERS cheat sheet. Doesn't really matter for the plans examiners, but the builder might want to take a look at this and just understand if they're dealing with a QII. And again, we'll get on to that at the next presentation and what that triggers for some of these. For the water heaters, basically column 3, column 5, column 7 are the ones to spot check. And if there's a recirculation system, you're going to want to see that it matches the plan set. And that's going to be listed under distribution type. If it says standard, there is not anything to do about it. If it's got a recirc, okay, then you're going to want to look at that. And the number of units means how many water heaters are in the project. So it's a quick spot check to see if the quantity is correct. And column 7, compact distribution. If it says none, don't worry about it. If it's expanded, that's going to trigger the HERS rating, and you should see some linear takeoffs on the plan set. But we'll talk a little bit more about what happens here in our upcoming courses. For water heaters that are a NEA heat pump, NEA rated heat pumps, it's got its own table. And again, you're going to want to spot check that the number of units is there. And then column 4 and 5 has to do with the NEA brand and model. And when this is actually chosen by the energy modeler, you're going to want to see that a ream and that type is called out on the plans. And that's something that would need to match for the actual construction. And again, if it's triggering the CF2Rs, 3Rs, we're going to hit more on that on the next one. And then the tank and duct location. This is a little interesting. These things, I'm of the opinion that I think some of the print for the column 7 and 8 may not be printing exactly correct. So anyone from the CEC, I'd like to talk to you more. I think it came up in our KVET conference as well. But mostly what we look at is the tank location, because it is it'll tell you if the tank is located in the garage, or if it's located inside the house, or if it's located like outside, as in an outdoor utility closet. And then there are some other water heater types that I'm not showing you, but if you have a heat pump that's not NEA rated, there's going to be an efficiency metric range to deal with. You could have a gas water heater. It's going to have its own little table, and you might be in a situation where you could have electric resistance, like if it's an alteration and it's a replacement and it's in there, or if amazingly you had a 500 square foot or smaller house that could benefit from an on-demand electric water heater, that would show up as its own table.
I think it's worth noting, if you go back real quick, I'll be fast.
Okay, yeah.
The tank location, the reason why it's important is that the heat pump water heaters are more efficient, operate more efficiently when they're located at a place of higher ambient temperature. So a tank location being in conditioned space will give your project credit, which can, if it's not in conditioned space, that gets caught by a HERS rater or inspector. They ask to rerun it. Now your project fails, and you're in that little spiral of trying to figure this out. So that's an important one, I think.
Yeah. Yes, that's right. Yes.
Cool.
Exactly. And the water heaters. So this is kind of HERS verifications, what got triggered. So again, for a compliance, a number of these things could be triggered, and they're listed. Each sort of measures listed out in those columns 2 through 7. And here you're looking to say, hey, is it required or not? And in this particular example, we didn't take any of these credits or HERS measures on this, but we'll go over a little bit more about what each of these HERS measures entails, like with the compact distribution or parallel pipe if needed. But this is where you would find it. So this should be of great interest to the builder. If you see a bunch of these are saying yes, required, that should trigger the builder to look deeper into this. For the space conditioning systems, HVAC, and kind of those HERS verifications. For the space conditioning systems, basically all these values should be confirmed. It's what system type. is it? And how many of them are there? For the HVAC heat pump specifically, I use this heat pump as an example. It triggers a lot of HERS verifications no matter what, because here, if you take a look at the next table down where it lists those verifications, these things, they're related to each other. If, depending on how it's modeled, you might have the airflow needing to be verified, but also depending on which credits you're taking and how it's done, the HERS rater might need to come out and verify the efficiency listed as a EER2, or the other part of the seasonal efficiency, SEER2, or verified refrigerant charge could be a standalone item like it is in this case. And the heating capacities at 47 degrees Fahrenheit and the capacity at 17 degrees Fahrenheit need to be verified. And sometimes the heating efficiency, known HSPF2 is the new metric, those also might be triggered. So this table is important for builder. And of course, your HERS rater, not so much for the plans examiners. And then the HVAC distribution systems, I'd say this could trigger something for the plans examiner to note, and specifically in column 2, type. And you would just note if it's no ducts at all versus, say, ducts in the attic versus ducts in conditioned space, or it could be ducts in crawl space. And a lot of these things are going to be triggering HERS verification measures, such as duct leakage, or if there's bypass duct design, which would be a whole nother way of inputting this. The kind of last item on this whole checklist is the indoor air quality fans. And this is your outside air requirement fan. A lot of times it's listed as a table. A lot of times a default value is being used. And through Cal Green, you would have the HERS person come out and verify the airflow and the fan type. And as a plans examiner and as your builder, what you're going to be looking at mostly is column 4, which is the IAQ fan type. And that might be a balance system, which means you're going to have a supply and an exhaust. So do you have 2 fan systems, or is it part of a system that has energy heat recovery like a Rensar or Zender or Luno system? And that will trigger the HERS verification. But if it's just your straight up default bathroom exhaust fan, you will still have to verify, not you, there's a plans examiner, but the HERS person will come out and just verify that the airflow is met and that it's an exhaust fan, and kind of end of story. And then very last thing would be a signature page, which I did not bother making a copy of. So that brings us to this last little bit, which is what to check on a 2022 CF1R per 01 for building departments. And this is the kind of cliff notes to go along with that to try and help speed up the process for the plans examiner, which also could be useful for anyone else interested in better understanding Title 24 CF1R. And in closing, I'm going to let Sarah pick this up and remind you of a few upcoming classes, including, but I'm going to highlight the November 29th because that's the residential compliance forms for occupancy. So we're going to go over the CF1R2 step, but now we're going to hit in what does it really look like for on the HERS side of it. And Paul Dunn, who is a local HERS rater, will be with me on that class. Okay, thank you.
Thank you, Jennifer. Yeah, and as a reminder, there are learning units for today's course, both AIA and ICC. And then we'll be sending out the recording and the slides as well as a survey out to your emails. It'll go out in the next 2 to 3 days. And then, yeah, in addition to the residential compliance forms for occupancy course, we have a few other Energy Code Connect courses that are upcoming. And I also linked our event calendar there, as well as we have some other courses that I did not list. And with that, we are at time, but we can open it up for a few questions for those that want to stay and have any questions. But for those that need to get going, thank you all for joining us. And yeah, we'll stay on for a few minutes and see if there's any questions.
I have one from earlier from George, but I want to give anyone else the opportunity to ask questions specific to this presentation and these topics. And then if no one does, George, we can try to hit that real quick. Feel free to unmute.
I just had one comment on your the two items that everybody needs to be aware of is the exhaust fans for the kitchen and exhaust fans for the bathrooms. They have to meet. Right. Yeah, they have to meet the actual CFM listed on the form, but also they have to be on the registry. And if they're not gonna pass. So that's something that whoever's installing needs to make sure that the units that they have on there, they're gonna be not only CFM ready, but be on the register as approved items.
Absolutely. Thanks, Javier. I hope you're going to attend the next one. We're going to talk a lot more about the specific HERS verifications and the association between the tests themselves and what we're looking for, and what that looks like on the original form, and why that consistency needs to happen.
Yeah, we've been seeing some of those things too. Gosh, well, like what Grant said, it's like, okay, you just get that, you get in this crazy loop with the builder and the consultant and the HERS rater. It's just, yeah.
Sorry, Javier, you're muted again. We're missing.
Oh, unmute.
Yeah, I was going to say that more and more you need to be there at the beginning of the build, because there's a lot of things that even as soon as they finish concrete, there's an item there for the seal. If you're going to go after QII, that needs to be there. So if you're not there, then you're something that they just missed blatantly, you know. So yeah, it's definitely, you need to be there early on.
Absolutely. Yeah, that kickoff meeting, we always try to promote that kickoff meeting before construction with your HERS rater. And a lot of our clients will go, wait, we need a HERS rater? Oh no, then we're in a world of hurt already.
I shouldn't laugh. I should not laugh. That would be something, I think, that like the architects, I mean, it's not really part of this, but if we have any architects on the call, I think they should just have a big stamp, or maybe a planning and building department, just like they get the plan in and they just stamp it that says HERS, required no matter what, something. Yeah. I don't know.
Does anyone else have questions? Otherwise, I'm gonna hit yours, George. Is George still here? George is still here. Please, anyone else, if you have questions, unmute or shoot it in. This one's a little bit off topic, and Jennifer, we can do this offline with George if we want to, but I thought I'd give it a shot. George, if you're here, can you unmute and ask your question again?
Yes, thank you. So I think I don't know everything I probably should know about the HERS rating process, but if you have an existing home and you want to initially understand it in terms of the HERS rating process, it's got a vented attic. I'm guessing it's possible to go ahead and do a blower door test and do the energy modeling to figure out what you've got. So, and I apologize for coming in just a few minutes a little bit after you started, if you already answered this question, but But what do you see as the points in the process of remodeling an existing house where the HERS rating process and or the blower door test should be done?
I'm gonna try to answer this bigger picture, Jennifer, and then you correct me. Um, I think the a HERS rater is a great building professional who has the skills and equipment to do what you might be thinking of as more like a home energy audit. So it wouldn't be necessarily from a code perspective precisely, but that individual is more than capable of coming in and doing a blower door and maybe giving you some consulting or advisement on what would be the best opportunities for your home or what the existing conditions are. Code doesn't necessarily step in before you've done anything and promote that investigative period.
Unless, say you've hired a designer, architect, and then they have their energy consultant and they're working on the Title 24 for the existing plus addition you might be adding or plus any alterations you're doing. And then at that case, sometimes in order to take credits for all the things you want to do, usually is like a trade-off. So say you want to add a lot more windows and perhaps you want to do something on the addition that would require more energy for that addition alone, then we can model the existing conditions of your house, and you might get the suggestion that you should replace your water heating system with something even better, or maybe you need to add more insulation to the existing attic. Then that HERS rater would go out there and specifically evaluate your existing systems so that we could include that in the energy model as a complete existing plus addition plus alteration way of looking at it. So there's a HERS existing conditions that's part of Title 24 compliance.
So correct me if I'm wrong, but I think you're building that model based on what could be high quality information from as-built or what could be garbage, right?
Yeah, so exactly what Jennifer was just saying. So if we don't have a HERS rater perform the existing conditions verification, you're not given credit for how poor the home might already be in its existing condition because of that reason, because it's unverified and you're right, it might not be correct, right? By having them come out on site, say, hey, look, these windows are single pane. Hey, look, this wall is uninsulated. And then it goes into the registry, they sign off on it, list out their report from their inspection. When we model it, then we can take credit, so being for showing the difference between that uninsulated wall and your proposed newly insulated wall. And that then shows up and is verified by your plans examiner inspectors.
So you get that change and that's worth something.
Yeah, because existing homes can be really hard to comply in a lot of situations. So that's oftentimes when I get a E+A+A project, that's the first step I recommend. Hey, get a HERS rater out here. Let's see what you're working with to start.
Thank you for that. I'm working with a set of plans right now where I noticed the original permit back in '85 included crawl space insulation and no slab insulation, and that was kind of funny because this is a slab on grade house. So whoever was checking the plans, I don't know what they were thinking, or maybe because they put carpet or something down. It's crazy. The other thing I notice is it's supposed to be R30 insulation. And having looked at the attic, I wonder, is it really R30? Is it performing as R30? So what do you recommend as a way to verify the actual insulation value of what is there?
I would call Javier or a similar HERS rater and get them out on site, and they'll look at the specified material, what that material is based on their experience, have an R per inch, measure the depth of it, And then because he's a HERS rater, he can already provide that existing conditions. You could do the same thing with a little, homework, identifying what that substance is, if you can find any kind of product.
Yeah, I know.
And
I know it's fiberglass and it may have a label on it, but that's a little bit different from my question, which is about actual performance. Does that make sense?
um, what do you mean by actual performance?
Like, what is the U of that
Ah.
specific installed condition?
You could use the Title 24 appendices for the framing, the depth of cavity, the type of assembly, and you can use those values to as a quick start without avoiding some of your own math. If you want to go deeper than that, you should talk to a building science consultant, and you can get very deep into the weeds trying to determine what the real U factor of that existing assembly is.
Okay, so you're not in a position to say, George, use this piece of equipment and you can verify the R value there or the U value.
No, no.
So I think that's very interesting because it could be moist, it could be dirty. A lot of things can happen to insulation, right?
Oh yeah.
Not to mention the air tightness issues, and once the insulation is down, it's in the way if you wanted to inspect for things like, company like termites or inspect for other things, right?
Yep. Yep.
So
Yeah.
yeah, so I have I
And then
consumed
it
all the time
takes,
available?
No.
yeah.
I mean, Jennifer and I
this
can
is,
talk about this for a while.
this is fun, right? Because then some of this is like experience based on like the folks who are doing hot plate tests through sample assemblies for the attics, for ceilings, for walls. Like they go through a lot of testing and come up with these like the parameters of what's generally accepted for understanding what the U factor might be for an assembly. So we're definitely dealing with, a range. So it's almost going to be impossible to tell specifically what your project is doing because there would be no way to set up a test to actually measure it. But we know, for example, that if fiberglass bat is compressed, there's been tests done on brands, and they'll look at it being compressed and they'll measure it, and then they'll give a range for what that product is expected to perform. But in ceilings, it's different because there's no, it's only touching a ceiling surface, so it's going to perform differently right there. And then if it's moist or dirty or moved, I mean, there's enough folks with enough experience, a lot of your HERS raters, you could take a look at it and just go, yeah, based on all this other building science that's done, that R30 is probably acting like an R8. And it would be close enough because basically if it's not performing like an R30 and you could tell, you're going to be able to tell a lot visually, then you're going to work with the designer or the builder, or maybe that's you. And you would spec out something like a blown in insulation that just blankets over the whole top of the thing and covers the cord. And you can measure it with a ruler and account for the compaction. And then you basically just fix it and you get it to perform the way you want it to perform.
Yeah, and when you talk about moisture and air tightness, these absolutely affect the performance of the assembly, but they don't necessarily affect, well, they do, but the resistance value directly through of heat transfer, if you have moisture concerns, the moisture concerns need to be remediated before you're concerned about the energy performance. Like that would supersede that issue. And so instead of focusing on the performance of that moisture issue and mold or whatever it is, we'd say, let's fix this mold. And when you redo it, unfortunately, let's then focus on the performance of this new assembly that can be done.
Yes. Yes.
All right, well, I just want to, sorry to end this conversation, but if you have any more questions, Grant and Jennifer are our energy code coaches. So you can reach out to them directly and they'll answer questions to your specific projects. We have a phone number and we also have our web form on our website that you can fill out and submit. But with that, I'll go ahead and end the course today. Thank you again to Grant and Jennifer, and for all of you for joining us, and have a great rest of your afternoon.
Thanks, everyone.
Thank you, everyone.